Well, in this session, we want to talk about the Grand Canyon. And of course, this will be a lighter way to finish the day. I hope not to make it too heavy for you. But the Grand Canyon does provide a testimony to the biblical account of Earth's history. And it's a spectacular place to visit. I've been there, visiting there for almost 20 years. Last week I was rafting down the Colorado River, and I've been down about 20 times now. And I'm always learning something new. And in a week or two's time, I'll be going again to look over the rim for a new project that Answers in Genesis is working on. And of course, this is the view inside the canyon. The last view was from the south rim of the canyon, where most people visit. This is actually from mile 137, from the top of a waterfall that you have to climb up to, a waterfall that cascades into the river. And in fact, at the middle there is the narrowest part of the canyon, 76 feet wide. It's the granite narrows, and you can see the full sequence of rock layers all the way to the rim. And it truly is a spectacular sight. There's no other site on Earth, really, that matches the scenic grandeur or the scale of the spectacle. In fact, it's one of the few places on Earth that can be seen from the moon. That's the scale of the canyon. It stretches some 277 miles through northern Arizona, which, of course, on the license plates, some of them has the Grand Canyon State. The main portion of the canyon attains a depth of more than a mile, and you can feel that mile when you have to climb out of it by foot. And the width ranges from 4 to 18 miles, so it really is a big hole. And the Colorado River cascades down along through the canyon, generally 2,400 feet above sea level, but where we launch at Lee's Ferry below Glen Canyon Dam, by the time we helicopter out at mile 187, we've fallen through more than 1,000 feet, which is why it's some of the best whitewater rafting in North America, with in fact the fastest navigable rapid, with the water flows at 27 miles per hour. And it's 17 seconds of terror. But the interesting thing is, the canyon cuts through a plateau, 7,000 to 8,500 feet above sea level. And that's the enigma that the conventional scientific community cannot solve. Why would a river cut its way through a high plateau? Normally, wouldn't it go around it? Why would it go right through it? Because here we can see from space, this is a NASA photograph. This green area here, of course, is due to the forests. The elevation is such that the Kaibab Plateau, this is the area here, the north rim, the south rim, the vegetation is different, so it shows up differently on the satellite photographs. Here's the Colorado River, and it cuts through it actually takes this is the high country. This area here is lower, at a lower elevation, and it does a 90-degree bend cutting through this plateau. And in the latest book on the research, and they had a big conference at the South Rim several years ago on how did the Grand Canyon form, in summary, they're still mystified as to why it cuts through a plateau and does a 90-degree bend. And this is what it looks like inside. It's a great place to visit, and AIG has regular rafting tours through the Grand Canyon. I'd love to see some of you on those trips. And of course, it's a wilderness area. No telephones, no emails, which was great last week, but I'm paying for it this week. And it's an incredible place to explore. And, we had a group of Christian leaders and scholars in the canyon last week. And, the solitude, reflecting on God's creation, really does something to people. And they come out of the canyon. Invariably, we hear testimonies that being in the canyon was life-changing. And so can an understanding of the geology be life-changing as well, because it's a testimony not to billions of years, but to the biblical account of Earth history. And of course, it's readily accessible as a geological observatory. The reason why I knew all about the Grand Canyon before I first visited it is because I always read about the Grand Canyon in all the textbooks that I studied at university. Because it's one of the few places on Earth where the rock layers are exposed to view in such a confined area. Normally you see a few of these layers here and a few of these layers there, but you can go down the Colorado River, progressively going down through the layers, and you can see them all up there above you for mile after mile after mile. And it really is a detailed representative sequence of rock layers that span a significant portion of Earth history, which is why it is a magnet for geologists. The interesting thing, by the way, is the first geologist to go through the Grand Canyon was only in 1869. John Wesley Powell was a geologist. He became the deputy director of the US Geological Survey subsequently. And that span of Earth history that we see in the canyon itself is actually increased because further to the north, we have what is known as the Grand Staircase, and I'll show you an illustration of this in a moment. Many of you are familiar with Zion Canyon and Bryce Canyon to the north. Well, they're actually at a higher elevation into higher rock layers that are formed above the rim of the Grand Canyon. The Grand Canyon is only the beginning of the story. There's even more rock layers higher above, which give us an even completer span through Earth history. Well, this is how we do it. There it is. That's the rafts we travel on down the canyon. They're 35 foot long, 14 foot wide, perfectly safe. That's why you wear a life jacket. And we stop at different side canyons to explore. I mean, the beauty is not just around the river, it's also in the side canyons, as you can see in these photographs. By the way, the one on the right isn't there anymore because late last August, there was a thunderstorm above the Havasupai village and it burst through a dam that they had for their water storage, and a lot of water in a little bit of time ripped out those waterfalls. And that's what happens. That's why you have the rapids, because thunderstorms, the Colorado River isn't strong enough to keep its channel clean anymore. You get because of the dams. You get a thunderstorm in one of the side canyons, and you get all this debris flows down into the Colorado River and goes bonk, and it blocks the Colorado River and forms a rapid. Well, it's great. Back in 1966, there was a 40-foot debris flue came down out of Crystal Creek, dammed the Colorado River, and everyone was too afraid to raft over it for a few days until it had burst through and started to, and it's one of the 3 worst rapids in the canyon now. Well, here's the sequence of rock layers in the canyon. This is a geologic diagram. It's not all that difficult to understand because you can see the profile of the canyon. Okay, we've got the outer canyon and we've got the inner gorge, what is called the inner gorge. There's a canyon within a canyon in the Grand Canyon. You've got the wider, broader area where you see all these steep walls with the cliffs and slopes with these horizontal sedimentary fossil-bearing layers. That makes up about 4,500 feet. Underneath you've got some inclined sedimentary strata in some locations, or these horizontal rocks sit directly on the basement crystalline granites and metamorphic rocks, and we'll see some photographs of these shortly. In the Western Grand Canyon, we also have evidence of lava flows that are so recent they flowed down the walls of the Grand Canyon after the canyon had formed. And we're going to work through this sequence of these layers tonight to unravel what they mean in terms of the history of the Earth from a biblical perspective. And you can see some names there, the names of the layers. You see there's a sandstone up here and there's a sandstone down there. We all know what sandstone is, don't we? It's sand that turned to stone. So it's not difficult. I'm going to make you geologists by the end of the night. But how do we know the difference between, how can we tell the difference between these two if we write about it? Well, we give them a different name. So this is called the Coconino sandstone, and this is called the Tapeats sandstone. they give them different labels so you know which sandstone you're talking about. So it's not highly confusing. The way geologists name things is quite simple. Well, I told you about this grand staircase. Here we see the Grand Canyon, okay? But above, and here it is here, but above the Grand Canyon, there are more layers of rock that have been eroded into a step-like feature, which is called the Grand Staircase. You have coloured cliffs. You have the chocolate cliffs, the vermilion cliffs, the grey cliffs, the white cliffs, and the pink cliffs. The white cliffs, of course, sorry, there's the white and there's the grey. The white cliffs are at Zion National Park. If you've been there, you see the white cliffs of the Navajo sandstone. Up here in Bryce Canyon, you've got the pink cliffs with all those erosion features with those pillars, etc. And so you've got about 4,500 to 5,000 feet of sedimentary fossil-bearing layers down here in the Grand Canyon, but there's another 10 to 12,000 feet through here. And so these are stacked on top of one another to produce a total picture from the crystalline basement rocks right through until the present era at the top of what is known collectively as the Colorado Plateau. Now here we're standing across from Lee's Ferry, which is the launching point for the rafts, and we're looking downstream, down the Colorado River, and we look across the river, and here we see these cliffs of the Grand Staircase. The rim rock of the Grand Canyon is down here at river level. The rim rock that you stand on at the south rim is down here. And we have these other layers, part of the Grand Staircase, over here. Here we can see some of the vermilion and chocolate cliffs, and up there, the beginning of the white cliffs. And so there is evidence that these rock layers were stacked on top of one another. And they form a very good geologic record in this part of the world, and which was why, as I said before, it's a mecca for geologists, because it's a very well-exposed sequence of rock layers that people can study. And here are the white cliffs in the Zion National Park. The rock on the left you see as you go in to the park from the east is called Checkerboard Mesa. This combined sequence of strata from the Grand Canyon through the Grand Staircase right up to Bryce Canyon, as I said, have been saying, is a very comprehensive span of Earth history, and it provides an ideal location to directly correlate and equate by direct observations the different levels of rock layers in this cross-section that match the various levels, the various parts of the biblical account of Earth history. And also, these rocks contain fossils. And the order of these fossils, might surprise you, matches the order we see in the textbooks for the fossil record. And for some of you, this might create an enigma, but I want to unravel that a bit tonight very quickly. And I've written an article just recently, which will be in the first issue of Answers magazine next year, on this same area about the fossil record in these rocks and why we get the pattern and order that we see in these rocks. It does match the order of the widespread fossil record in the so-called geologic column. Don't be shocked by that. You see, we've got to grapple with the real data with integrity, and we do find these fossils in a distinct order in the fossil record. Why should that be a problem? We can go to the Scriptures, because the Scriptures provide the answers. God's written record, He was there, He has told us what happened, and we just have to fit the pieces of the puzzle together based on what He's shown us in His world. And so these two observable realities, the extensive strata sequence and the order of fossils in it, both of which match the geologic column, so-called geologic column, make it imperative that we look at how both can be explained within the biblical framework of Earth history. What is that biblical framework of Earth history? Let's remind ourselves tonight. It began with Creation Week. And on day one, we had the initial creation of the earth. Now, someone has already asked me, would the earth, when God created it, have had the core, mantle, and initial crust? Possibly. We're not told. Or we're told that he created the earth, and we're told the condition in which it was covered in water. We're not told what was under the water. But from a geologic point of view, it makes sense for God to go the whole way as quickly as possible and produce that structure of the core, mantle, and crust initially. And there's a lot of geologic evidence that would support that. Although, of course, remember, we are looking through a dark glass sleeve. We're in a post-flood, post-fall world looking back to the time of creation. So we have to be very tentative and speculative without being dogmatic. But what we do know is that on day 3, God formed dry land. Why do we know? Because he tells us. He gathered the waters together into one place and made the land appear, and then he put grasses and vegetation on it. So that must have involved earth movements of some sort. There must have been a reshaping of what was under the waters, because some of that had to be raised and some of it had to fall to accommodate the waters that were going to drain off the raised areas. But the raised areas, what would happen? If it was rocky material, the water flowing off would erode it. It would produce sediments. And so there on day 3, you'd actually have sedimentary rocks formed. But they'd have no fossils in them, would they? Because there'd be no life. That's why it's interesting that if you go back to what the geologists call the pre-Cambrian, you have lots of rock layers with no fossils in them. And they're sitting on crystalline basement. It sort of gives us a clue, doesn't it, to what's going on here. And we're going to illustrate this shortly from the Grand Canyon area. Well, the creation week continues. Day 5 and 6, we have the marine, flying and land creatures. So now we have the critters that are now living in the oceans, the land, on the land and in the air. On the land that now has become stable, the oceans that have become inhabitable, and the air that's free of dust and all the rest of it, so that the critters can fly around safely. But because of Adam and Eve's sin, death came as a result of the curse that God placed on the earth, and so the earth starts to degrade. Things start to go wrong. Now we have the potential that there is death, and there could well be, we haven't got a major amount of sedimentation in the pre-flood world because it's still a very habitable earth. It was sort of perfect, and now it's sort of near perfect. It's starting to degrade. So we may only get trivial sedimentation, minor sedimentation, and trivial fossilisation, because we know that fossilisation requires catastrophic processes for rapid burial, deep burial. But there is examples of things that might have been fossilised in the pre-flood world. Again, from the Grand Canyon, I'll show you in a minute. Then, of course, we have the global devastation of the flood, which, of course, is the one area that we focus on a lot from a creationist perspective. Not a lot has been talked about the pre-flood earth, but that's another area that I like to dabble in, because a lot of Australia, in fact, 2/3 of Australia, is probably made up of pre-flood rocks. And a lot of Canada is as well. So we're more interested in some of those rocks in our part of the world. And of course, after the flood, early after the flood, we had the Ice Age, as I illustrated on Monday night. Because of the hot waters left over from the flood, more evaporation goes to the poles, and it condenses snow and ice to form the ice caps. And so the evidence geologically is that there was residual catastrophism on a local scale during that period. There was still potential for burial of critters. Interestingly, where in the world is the only place that you find fossil kangaroos? Australia. Where do we find kangaroos living today? Australia. When did the kangaroos get to Australia? After the flood. So when did the kangaroo fossils form? After the flood. They're in local little cave deposits. So there was some catastrophism that produced some fossils, residual but localised. And from the end of the Ice Age, remember, we're still living in the effects of the flood. We still get the occasional earthquake and the occasional volcanic eruption, but it's been declining and less catastrophism. Until, of course, when Jesus returns. Then things are going to hot up again. Okay, so next, with that framework, let's now start. The best place to start, the most obvious place to start, is let's try and identify where the flood strata are in Grand Canyon. Because once we've identified those, we'll know what are the pre-flood strata. Okay, so let's start by looking at what would be flood strata. The lowermost horizontal sedimentary rock, and I'm going to show you with the diagram again in a moment, the lowest horizontal sedimentary rock layers in the walls of Grand Canyon is the Tapete Sandstone. You all know that already, don't you? Because I told you there was the Coconino Sandstone and the Tapete Sandstone. See? You've learnt something tonight. And the sedimentary rock layers below it are tilted and devoid of any significant large, visible, that's megascopic, fossils, apart from some algal-built structures called stromatolites. And I'll illustrate those for you a little later on. But this gives us a clue. Remember, our biblical framework says that rocks prior to the flood wouldn't have fossils in them. And at the beginning of the flood, there would have been upheavals. And upheavals can tilt rocks and erode them off. Therefore, we've got horizontal layers sitting on an erosion surface at the bottom of the Tapete Sandstone. That is the obvious place for where the flood began. So, as I said, there had to be a violent upheaval in these earlier rocks that tilted them and then eroded them off. There's a flat surface which goes the whole length of the Grand Canyon. It's called the Great Unconformity. Now, let me unravel that for you quickly. Something that's conformable means it's parallel. They're conformable with one another. They're the same disposition. Unconformable means they're different disposition. The layers below are tilted and the layers above are horizontal. They're not conformable with one another. So the boundary between it is called an unconformity. And so the Tapete Sandstone was deposited directly on that erosion surface. It was tilted up, eroded off, and then the rocks beneath were all eroded off, and the Tapete Sandstone is sitting on top of it. And the violence of that deposition is evidenced by the huge boulders that are found in the base of the Tapete Sandstone. And also the beds of sand that make up the Tapete Sandstone are very similar to the beds of sand that are formed on the east coast of the US by hurricanes. And most geologists recognise them as storm beds. Well, here we're talking about the Tapete Sandstone down here. These are the inclined strata that I was referring to. And obviously something occurred which caused them to be, they were originally deposited horizontally. Something has caused to tilt them up, and then it's been eroded off. They've been, so it means you have earth movements tilt them up, and water comes shooting across to erode them off. And as that water comes over, what's it going to do? It carries sand and boulders and starts laying it on there. This shows you that this is the initial start of the flood in this area. The breaking up of the fountains of the Great Deep, causing earth movements, earthquakes, things shifting around. Rock layers are going to be tilted. The water, as the tidal waves and tsunamis keep coming up onto the land, is going to bring up the sediment, eroding off what was there before, and then laying down this sand. And so the Tapete Sandstone is easy to see. It's this little cliff above these tilted sedimentary rocks and the granite below. This is the view from the south rim down to the Bright Angel Trail. This is Plateau Point, which is a side trail from Indian Gardens on the Bright Angel Trail. The Phantom Ranch, which you can see from the south rim, is just around the corner. So any of you who have bought that guidebook to the Grand Canyon, of course, will know some of those locations. Here's the cliff of Tapete Sandstone. See, it's made up of multiple beds of sandstone. And here's this erosion surface. This is another rock underneath, which is at an inclined angle. The erosion surface, here are some of these boulders, and here's these storm beds of sand. equivalent to what we see hurricanes deposit today. And again, you can see the hand for scale. Some of these boulders are quite reasonable in size. And of course, the greater the size, the faster the water has to move to carry those boulders. But see these boulders here? You can see the man for scale. These are up to 15 foot in diameter. So you need fast-moving waters. I'd hate to have been standing around when the water was carrying boulders along that were 15 feet across. I tell you what, it must have been terrifying not to be on board that ark. Now, based on the Genesis account of the flood, we'd expect to find then, subsequently, in the flood strata above this level, the following evidences. And if you've been reading Answers magazine, you should be able to shout them out to me before I put them up on the screen. Okay? We should be able to find marine fossils in rock layers high up on the continents, indicating that the ocean waters had risen to totally inundate the continents. We should also expect to find, second, that these sedimentary rocks containing these marine fossils should stretch right across the continents where the ocean waters deposited them. Because if the ocean waters covered the whole earth, the ocean waters came up over the continents carrying sediment, so the resultant rock layers containing fossils would be right across the continents. And of course, we'd expect that these sedimentary rock layers and fossils should both show evidence of having been rapidly deposited and buried respectively. That is, the sediments rapidly deposited and the fossils rapidly buried. And fourth, we should expect the whole sequence of these sedimentary rock layers with the fossils in them should show evidence that they've been deposited one after the other very rapidly. And of course, the conventional scientific community, as we'll talk about in a moment, believes that in places between the layers in the Grand Canyon, there was millions of years missing. And so they might accept that some rock layers form rapidly, but if there's millions of years in between, they've rescued their millions of years timescale. If there's no evidence for millions of years between, the whole timescale collapses down to fit in with the biblical flood account. So it's very important that we establish that there was a rapid succession of these fossil-bearing sedimentary layers. Well, what about marine fossils in the Grand Canyon? Every one of these layers that you see arrowed there contain marine fossils, from the Tapete sandstone at the bottom to the Kaibab limestone at the rim. All of them contain marine fossils, shallow, apart there's one or two that don't, but all those ones arrowed have shallow water marine fossils, corals, clams, and other related critters that you would normally find if you went scuba diving on the shallow ocean floor around an island or off the coast. Here's some examples. We find trilobite fossils in the Tapete sandstone, at the top of the Tapete sandstone and in the Bright Angel Shale. We find brachiopods. Brachiopods were lamp shells. They were similar to clams, but they had two different sized shells. They still hinged. And the brachiopods are actually found from the bottom of the fossil record to the top. Some of these brachiopods haven't changed in 500 million years. They're exactly the same critters. They didn't evolve into anything else. They've stayed the same. And then we've got crinoids, which are sea lilies that were actually not plants, but little animals. They had discs that were stacked on top of one another to make a stem, and then had fern-like leaves, so fern-like arms that swept in particles for them to eat. And then bryozoans are lace corals. We still see them on coral reefs today. And on the right there, you can see a sea urchin spine. So these are marine fossils found high up on the continent. And you remember what I said on Monday night, how significant that is. The fossils aren't found in the oceans, they're found up in the continents. If the ocean waters flooded the continents, that's exactly what we'd expect from the scriptural account. All the high hills were covered in water that rose up from the ocean basins. Now here's the pattern of burial of fossils in the burial order in the Grand Canyon area. And this is interesting. Shallow water marine vertebrates are found all the way through. We don't find fish scales or fish teeth initially, but a little later on. And we don't find plants or vertebrate trackways until higher up But we find the trackways, but not the bodies of the animals. The bodies of the animals are actually found up in the Grand Staircase above the rim rocks of the Grand Canyon. So, when the flood started, where did it begin? In the oceans. And as the ocean water rose up onto the continents, which critters would be the first to be affected by the advancing floodwaters? All the critters that lived on the shallow ocean floors surrounding the continent. Is it surprising then that the first creatures we find buried in the fossil record are shallow marine invertebrates? Absolutely not. As the waters began to choke the ocean waters with all the mud, what do we find? Fish start getting fossilised, and we see fish in a position of being asphyxiated because of lack of being able to cope. Then as the ocean waters rise higher and start depositing up in the area where plants and animals move around, we find their remains. But why would we find the footprints before the body fossils, the bones? And this is an interesting observation. Everywhere in the fossil record, we find the fossilised footprints at a lower level than the bodies. Okay, and sometimes it's millions of years apart. Hang on a minute, if it was millions of years, why wouldn't you find the animal buried with its footprints? But in the flood, what happens? Remember, you have a tidal surge as the ocean goes up and down in the cycle of the moon. You have the high tide coming up. The low tide comes, it drops. The animals that are swimming in the water leave their footprints and they get swept away by the next high tide until they run out of breath and then they're buried and fossilised. See? A biblical flood perspective explains that pattern. Footprints at a lower level before you get the body fossils. The same with the dinosaurs, believe it or not. The birds, the mammals. The pattern is the same in the fossil record. And we can explain it from a biblical perspective. So, as I said, the shallow water marine invertebrates are found in nearly all these Grand Canyon sedimentary rocks, from the tapetes at the bottom to the kaibab at the top. And this is consistent with the rising ocean waters carrying these creatures from the fringing pre-flood ocean floors up and across the continents. And the more mobile fish survive longer in the floodwaters before succumbing and being buried. And the land plants and animals were only overwhelmed and buried as the floodwaters progressively inundated different pre-flood ecosystems at different levels, at different altitudes. Just like if you were to flood the Grand Canyon today and bury the critters that are living there, you wouldn't get ponderosa pine at the Colorado River because the ponderosa pine are at the top on the Kaibab Plateau. You got cacti down the bottom. You don't find ponderosa pine and cacti living together. So they wouldn't be buried together unless any floodwaters mix them up. So that's another reason why you would have differences in the pattern in the fossil record as a result of different ecosystems at different elevations progressively being buried. And we've already talked about this in Answers magazine a couple of issues ago, and you can go back to that and refer to a diagram which shows that. And I mentioned it again on Monday night. And as I said, the creatures left trails, the vertebrate creatures, the footed creatures, left trails and tracks before they were eventually being buried. Actually, it's not only the vertebrate critters. I'll show you an example in a moment, just to remind you of this order. Let's go down to the Tapete Sandstone. Guess what we find down there? This is really cool and exciting. We find the trails of the trilobites. The photograph on the left is fossilised trilobite trails. These little critters had little arms to move them along. That's why you see these double trails. These guys were scurrying along in the sediments as the floodwaters were rising and managed to escape, but then bingo, they eventually got buried. We find the trails at a lower level before we find the body fossils. How about that? Again, it fits with the flood. If this was millions of years apart, why weren't the trilobites buried alongside their trails? And here's some of these fossilised footprints in the Coconino Sandstone. Okay, they're not just single footprints, you can see the claw marks. Here's the left, right, and you can see it here. And I'll show you something interesting about this in a moment. We'll come back to those trails because it's an exciting story. And we show people, that's one of the places we stop on our raft trip. Have I twisted your arm to come with me down the Grand Canyon? Well, let's have another look at this Tapete sandstone again. You know, there's a bit of repetition here, but it doesn't hurt because each time I repeat, I add something else to the story. And the Tapete sandstone, as I said, remember that erosion surface and the boulders? And above it are the storm beds, okay? And I showed you this on Monday night. Here's the extent of the Tapete sandstone and its equivalents. We can find them right across North America. Remember what I said? We ought to find evidence in the flood layers that the waters went over the continents, taking sediment with them, so we'd expect to find rock layers that go right across continents. But the exciting thing is we find it also going to other continents because we find the same sandstone on the same erosion surface with boulders and storm beds here in southern Israel. This is in southern Israel. That's the Nubian sandstone, which you also have at Petra, which is the rock that the dwellings are in at Petra, and it's the same sandstone over in Egypt. And it's exactly the same as the Tapete sandstone. Transcontinental sedimentary layers deposited by the flood. Well, let's go a little higher and look at the red wall limestone. By the way, do you know why they call it the red wall limestone? It makes a red wall. Hey, that's pretty simple. And why is it red? Well, it's red not because it's red inside. If you break it away inside, it's grey. But you see that rock above? The rock layers above are full of iron oxides, and water trickling down the cliffs carry the iron oxides and colour it red. And again, here's some of the fossils. That's the brachiopod, and we've got the crinoid and the crinoids, the coelae, and the bryozoan or lace corals there. And the interesting thing is the same limestone at the same strata level with the same fossils in it is the Monte Cristo limestone in Nevada. It's the Madison limestone in Montana and Wyoming. It's got a different name again in Tennessee and Pennsylvania, but it's the same limestone layer right across North America. And in fact, you find the same limestone at the same strata level with the same fossils also in England and in the Himalayas. I mean, what more evidence do you need that there was a global flood when you see you can trace these rock layers and correlate them from continent to continent? The evidence is there, and even the conventional scientific community recognises the extent of many of these layers. For example, the Coconino sandstone, you remember that, I pointed out before, it's high up in the walls of the canyon. You can see it in the distance there. Some people nickname it the bathtub rim of the Grand Canyon, but it's easily visible. And higher up in the Grand Staircase at Zion National Park, we have the Navajo sandstone, and it's checkerboard mesa near the eastern entrance to Zion National Park. Now, interestingly, the evidence in these rock layers from the mineral grains, and this was in Answers magazine as well, the evidence of the Coconino sandstone shows that the sand to make up the Coconino sandstone had to be transported from the north, a large distance. Just several years ago, there was a study published in the journal Geology, published by the Geological Society of America, where analysis of grains in the higher Navajo sandstone exposed in the White Cliffs in Zion National Park correlated with those grains being eroded from the Appalachians. In other words, they had to postulate the sand grains were transported right across the North American continent to be deposited in the southwestern US. Of course, they couldn't explain how that happened. Well, there may have been some ancestral river, but they don't have the evidence for it apart from these grains in this sandstone in the southwest. But of course, a global flood, when the ocean waters came up and across the continents, it makes perfect sense. In fact, we find evidence in rock layers that indicate the direction in which the water currents were flowing, as we'll see in a moment. And at this time, the water currents direction indicators indicate that the waters of the flood were flowing from northeast and east to southwest and west. Interesting, because here you have other direct evidence of grains eroded from the Appalachians and deposited down there in the southwest. Remember what I said on Monday night? The Appalachians were formed as a result of early collisions of continental fragments during the flood, the early part of the flood, so that there would be subsequent erosion in the later part of the flood, which of course matches what we find here at Zion Canyon. These rocks are higher in the sequence. That suggests that the Coconino Sandstone and the rock layers in the Grand Canyon were the early part of the flood, and the Zion Canyon Navajo Sandstone was later in the flood, after the Appalachians had formed early in the flood, with the water currents flowing right across the country, eroding from the Appalachians and depositing the sand down there. See how the pieces of the puzzle can be fitted together within the biblical framework of Earth history. Again, we go to the the Tapete Sandstone. Again, we've got this erosion surface and the boulders, and again, we've got these large boulders. And again, remember, this is all evidence of rapid deposition. With boulders that size and storm beds indicative of hurricane velocity winds and water currents as a result, we're talking about devastating conditions that, of course, carried material right across the continent. In terms of rapid sediment deposition and fossil burial, we'll go back to the Coconino Sandstone. And again, to remind you where it is, and to remind you that it covers 100,000 square miles, average thickness of 300 feet, and it represents 10,000 cubic miles of sand that was transported and deposited as this layer. Now, within the Coconino Sandstone, on the left you can see a full view on the Bright Angel Trail, the main trail from the South Rim down to the Colorado River and Phantom Ranch, the full thickness of the Coconino Sandstone. Within that sandstone, as you look up close, it's a flat-lying sandstone, but within it we find these inclined beds, which geologists call cross beds. Well, that's right. They're at an angle, they're across the horizontal extent of the bed. What do they mean? Well, they are indicative of underwater sand waves. Now, in conventional thinking, these cross beds are supposed to represent sand dunes. And so they'll often say, well, you geologists who believe in the flood can't be right. How can you have a desert in the middle of a flood? Well, the interesting thing is, let me explain to you how these cross beds form. Whether it's wind or water, what happens is the wind or water causes it to mound up, and it heaps it up, and it drops it over the front and erodes from the back. So what happens, you keep on reducing the size at the back and extending out the front, and if you've got one after the other, the one behind is going to bury the one in front, but it's going to take some of it off. So what you have is you chop off the top as you go along, and if you have successive flows bringing in more and more of these sand mounds or waves or dunes, you're going to get a series of stacked horizontal layers with these cross beds that represent the residual front sections of these waves or dunes. So is it water deposition or desert wind deposition? Well, the interesting thing is, in a desert, the angle at the front of the dune is always 33 to 34 degrees. Okay? If you jump off the Golden Gate Bridge, and I don't recommend it, but if you look down underneath in the channel where the ocean comes so rapidly through that channel into San Francisco Bay, the current has heaped up the sand into sand waves. And we can experimentally test the water flows that do this. We can do it in a flume tank in a laboratory. Guess what? The angle here is always less than 30 degrees for an underwater wave. So now we can empirically test whether the Coconino Sandstone was formed under desert wind or underwater. Okay? What is the angle of the cross beds in the Coconino Sandstone? less than 30 degrees, always. Isn't that neat? We've got an empirical test. We can see these different dunes and waves that form today. We measure the angles and we can go back to the Coconino sandstone and bingo. We dismiss immediately that this was a desert dune. It's totally compatible with a global catastrophic flood. As I said, we can do this experiment in the laboratory. We can work out the water velocities, the depth of water, and in the case of the Coconino sandstone, we can do a calculation. We know how high the crossbeds are. We can measure them. They're usually half the size of the original sand wave. And so in the Coconino sandstone, some of these sand waves were up to 60 feet high. The water would have moved along at 3 to 5 miles per hour so that the 10,000 cubic miles of sand would be transported in just a few days. Not millions of years to form that sandstone. And by the way, where do we find the footprints? You might say, how can you preserve footprints of these critters in a catastrophic flood? I know someone was going to ask me that, so I'm going to answer it. Where do we find the footprints? We find the footprints on this slope. What is the current doing at that slope? It comes around and drops to zero. So these critters were in calm condition. You can imagine these critters being swept along by the water and they're able to get into the back eddy and say, I can rest on this dune. But they suddenly realise the water's still rising. So what do we find? The footprints are going, the creature is climbing up that front surface because he knows the waters are getting higher. He's got to try and escape. And interesting, some of these footprints, they go left, right, left, and they stop and they continue over here, left, right, left, right. He's actually been swept off his feet and moved sideways before he gets his footing again and keeps climbing up. Isn't that great? And we enjoy taking people to see this when we take them through the canyon because it is exciting. And anyone who comes with us who isn't convinced of the evidence for the flood, they usually come out totally changed. Interestingly, above, this is in the beginning of the Grand Staircase, looking over from Lee's Ferry, we find this huge conglomerate bed, the Shinnerup conglomerate. And it forms the cap of this cliff. And it's interesting conglomerate. It covers an area of 100 square miles, it's 50 feet thick, and it's 2,000 cubic miles of conglomerate with boulders in it. And interestingly, in this conglomerate we find crossbeds, which indicates rapid water transport of pebbles heaped up as waves. Not sand, pebbles. That requires fast-moving water. Where on the earth today do we see waves of pebbles being transported over 100,000 square miles to make a conglomerate bed? Nowhere. So how can the present be the key to the past? Absolutely not. In fact, one place in Australia, we've got crossbeds in a conglomerate that are about 50 feet high. And you imagine that, the original wave would have been 100 feet high. The flood was a scary place to be. 2,000 cubic miles of pebbles and sand covering 100,000 square miles had to be catastrophic. The Redwall limestone. In that limestone we find within it a bed. The geologists regard the Redwall limestone as having been deposited in a calm and placid sea. But it was anything but, as I'll show you. In one section of the Redwall limestone we find these nautiloid fossils. Nautiloid were squid-like creatures that had a head like a squid and had a long straight shell with all those chambers. See those chambers? And it had a little tube down the middle which you could use to shoot water out of. It's similar to the jet engine, the same principle. Now, I say we because I helped Dr. Steve Austin with this research. This bed covers 12,000 square miles. It's 7 foot thick, so it's 24 cubic miles of limey material with these fossils in it. The density of the nautiloid fossils is approximately 2 or more every 10 square feet of rock surface that is exposed. And we've found these nautiloid fossils from the eastern Grand Canyon here all the way to the suburbs of Las Vegas. Frenchman Mountain, right beside Las Vegas. And so, but interestingly, and the answer, of course, is that, let me go back to it. The story is that those nautiloid fossils, I'll just scoot back to that for a minute, those nautiloid fossils, to be in such a widespread layer, we find big ones, we find small ones, juveniles, adults, all mixed up. Many of them are pointing in the same direction, which means a living population of nautiloids were overwhelmed by a catastrophic debris flow that took a matter of hours to bury up to 1 billion nautiloids. So it was anything but a calm or placid sea. In fact, many of the crinoids in the red wall limestone are broken up in pieces. The corals are every which way. You can see on the right there many of the corals. And a lot of the red wall limestone is made up of broken fossil material, testimony to the catastrophic nature of the deposition. So the red wall limestone had to be a catastrophic burial of a jumble of marine fossils in limestone in a fossil graveyard that stretches halfway around the globe, from the southwestern US through England across to the Himalayas. What about the deposition of rock layers in rapid succession? You see that line there? That's supposed to have 10 million years of erosion at it. Can you see any 10 million years of erosion there? It's missing. What would happen to a land surface if there was 10 million years of erosion? You'd have gullies, wouldn't you? And hills. It's not there. From one end of the Grand Canyon, you have a smooth boundary, which indicates that the shale beneath, that red-brown shale beneath, was deposited, the mud, and rapidly on top of it was the sandstone, with little time between them at all. Down further in the sequence, below this shale that we saw just a moment ago in the Hermit, below the Coconino sandstone, it's called the Hermit Shale, we get down to the next unit that is a sandstone. But at the bottom of the shale, we find layers of sand within the shale. What does that tell us? It tells us it was continuous deposition. We had sand being deposited, but before the sand supply was totally switched off, we had mud that started to come in. And so we started to have sand and mud layers deposited before all the sand stopped coming in, and we only got mud from there on up. There's not millions of years of this boundary. We have a switching off of one supply of sediment and a turning on of another, one after the other. And so this implies continuous, rapid deposition, not any missing millions of years. Well, we do find erosion in some places at some boundaries. Here we find erosion in the Muave limestone with the Temple Butte in the channel, or this dig out, because they're not really channels, they're just little isolated pockets of erosion, and the red wall limestone on top. By the way, that boundary there is knife edge, like the boundary between the Coconino and the Hermit we saw a moment ago. That boundary is supposed to rep 150 million years. And that's the only evidence we see of anything in between. And even that boundary there represents 100 million years. So it shows you that there was rapid processes sequentially depositing these layers. Well, here's the piece de resistance. This is the Tapete sandstone that's been folded through 90 degrees. If you've been reading Answers magazine, you'd already know all about this. And this is sandstone that's bent, and we all know what happens when you try to bend hard rock. It snaps. In what condition does rock have to be able to be bent? It has to be plastic, doesn't it? Still soft and wet. And so that means the Tapete sandstone still had to be soft. When would it still be soft? Soon after it was deposited. Guess what? The rock layers above the red wall and Muave limestone are also bent without snapping. And yet they're hundreds of millions of years younger, supposedly, in conventional time. Indeed, the whole sequence from the Tapetes at the bottom to the Kaibab limestone is all folded, smoothly without being fractured. Remember what I said? If this had to be bent when it was soft, could the Tapete sandstone have stayed soft with other layers stacked on top of it? for 300 million years until the Kaibab limestone was deposited on top of it? No. Well, how about a few months during the flood? We got plenty of water during the flood to keep everything soft? Well, of course. It means that the whole sequence had to be deposited rapidly during the flood, the whole sequence, and then be bent, not over 300 million years. Well, so we've identified the flood strata. So the rocks underneath have to be pre-flood rocks. And we can see that from the rim of the Grand Canyon. And let's look a little bit deeper. Here we can see in the inner gorge, this is the crystalline basement. We can see the Tapete sandstone. We can see some of these inclined layers here. And here we see an erosion surface on the top of this the crystalline basement rocks. When would there have been an earlier phase of erosion? If this was Creation Week rocks, when would there be an erosion? Remember what I said earlier? When the dry land appeared, we had uplift and erosion. So this would be the erosion surface as these prior to day 3 creation rocks were pushed up to form the dry land and were eroded off by the retreating waters. And some of these inclined layers would therefore have been formed at that time in the third day of the creation week. The crystalline basement rocks of granites and metamorphic rocks should therefore potentially represent the remnant of early creation week rocks. By the way, they're not in the condition that God created them in. Why? Because they've suffered the effects of the curse and of the flood since. And so, but we do know that they may have even been earlier sedimentary and volcanic rocks that were melted and metamorphosed and melted during these day 3 upheavals. We don't know for sure because we weren't around. We don't know what processes God used, just as we don't know what process Jesus used to turn water into wine. So we're treading on holy ground when we start trying to work out exactly what happened during the creation week. But the uplift on day 3 to form the first dry land caused the original waters to erode across the crystalline basement. And so we can see this erosion surface all through the canyon on top of this crystalline basement, often with these inclined sedimentary rock layers, the sediment layers being formed without fossils primarily before the end of the creation week, and then tilted up with the upheavals at the beginning of the flood. But some of these sediments may well have continued to be deposited on the ocean floor during the pre-flood period, especially near the top of this sequence, which is exposed in the eastern Grand Canyon. In fact, we find these, at one level, these stromatolites, which are structures built by blue-green algae that today, we find them still alive today, growing in calm conditions. For example, in Shark Bay in the west, on the coast of Western Australia, and in Lake Clifton, just outside the suburbs of Perth, the capital city of Western Australia. And in this part of the Grand Canyon, we find these stromatolites stacked up in a row, side by side at one particular level, suggesting that this was a reef in the pre-flood world that got buried either at the beginning of the flood or just before, even in calm conditions. It can happen. And you can read about those reefs, these stromatolite reefs. They're mentioned in one of those articles in a recent issue of Answers magazine. So again, here's the biblical framework. We've been started with the flood rocks, we've been to the pre-flood rocks, and we've even identified potential creation week rocks. Now let's go the other direction. Above the Grand Canyon, we have many more flood layers that were deposited in what is now the Grand Staircase. But what happened? Well, the end of the flood came, and what happened? We're told that the valleys sank, the mountains rose in Psalm 104. With things being shifted around, the earth was in a state of imbalance, and now things had to start getting in balance again. And so there were a lot of vertical movements at the end of the flood, and so we have the whole area of the Colorado Plateau formed at this time as these flood layers were uplifted and folded. And as the waters drained off this uplifted area, we had huge amount of sheet erosion. the water was flowing off en masse, and as a consequence, some of the harder layers formed that were residual and didn't get eroded as much formed these cliffs. And so over a huge area, something like 100,000 cubic miles of rock has been eroded off the top of the Grand Canyon through this Grand Staircase area. How do we know that? Well, south of the Grand Canyon, we even find mazes which are remnants of some of these rock layers higher up. So we know these rock layers covered a much larger area, and that would have been eroded off rapidly as you had initially sheet erosion. As the water started to drain, there would be en masse, just as the waves crashing onto a beach, when they first start to go back into the ocean, it's a sheet-like effect. But what happens? As the sheet water flow decreases, the flow starts to become more channelized. And you can see that as water retreats on a beach back into the ocean. Now, everyone agrees that this emerging plateau rose before the Grand Canyon was carved through it. Okay? So that's why we know the Colorado River could not have carved out the Grand Canyon slowly over millions of years. Why? Unless water flows uphill. Why? Because the headwaters of the Colorado River up here are at a lower elevation than the top of this plateau. So if the plateau was here before the Colorado River to cut through this plateau would have had to flow uphill. That's why the conventional scientific community has a problem in explaining the Grand Canyon. But instead, on a flood perspective, what happens? As this plateau rises at the end of the flood and the waters drain off, leftover floodwaters become trapped in this lower country. This plateau forms like a natural dam wall, and you get lakes of leftover floodwaters. And there's evidence of this huge system of lakes that was dammed up behind this Kaibab Upward Plateau, potentially containing up to 3,000 cubic miles of water, about 3 times the volume of Lake Michigan. How do we know? Well, if you go to the Bryce Canyon area, those erosion features in Bryce Canyon are actually the shoreline features of this lake system. And you can see it's shown up here. The lake system went all the way back up here into the Bryce Canyon area. And when that lake drained catastrophically, it eroded those features that we see both at Bryce Canyon and at Zion Canyon. So the lakes behind the plateau, were full of these leftover floodwaters, and we can see 2 of these lakes here. And here's the plateau that's blocking them and holding them up. But what's in the plateau? Limestone. Water loves to eat limestone. So it weakens the wall rocks, it weakens the natural dam wall, but you also have more rain after the flood. There's evidence of supersized hurricanes in the early years after the flood. And a lot of rain would cause flooding, which would begin to not only erode channels across this plateau, particularly if there were any leftover channels from the retreating floodwaters before that, but it would weaken that natural dam wall. And the evidence indicates that this southern lake, first of all, breached catastrophically and started to erode the canyon. Now you might say, does the conventional scientific community accept a possibility? Yes. It took 50 years to convince them, but J. Harlan Bretz, from 1923 through to the 60s, finally convinced that that was the way the channel scablands formed in the northwestern US, the Pacific Northwest. A natural dam of ice blocked waters in Lake Missoula, and within a few hours, all this water carved out the channel scablands through solid basalt as if it was as soft as butter. So we know it can catastrophically happen. And then the second lake was weakened and completed the process to deepen it all in a matter of days. By the way, just as a sidelight, do you realise that on Mars there are canyons that are far bigger than the Grand Canyon? You know what the explanation of the geologists for those canyons are? It was a lot of water in a little bit of time. Guess how much water is on Mars today? None. And yet on a planet that is still 70% covered by water, they can't accept that there was a catastrophic global flood. Well, here's the story isn't yet completed. After the Grand Canyon was eroded, there were also volcanic eruptions in the Western Grand Canyon. We have in the Western Grand Canyon volcanoes, particularly on the North Rim, and the lavas flowed down the rim of the Grand Canyon and blocked the Colorado River temporarily. In fact, some of these lava flows went downstream for over 80 miles and upstream for 30 or 40 miles as they came down into the canyon. And as they built up one on top of the other, they formed dam walls up to 2,300 feet high that dammed the whole Grand Canyon. But what happened? The basalt, when it cools, has fractures in it, and so within days, the water would bank up, fill up the lake, and start eroding a notch. And as soon as you start eroding, you get bigger and bigger and bigger, and it would just catastrophically blow the whole lot out. And even the conventional community recognised that these were short-lived. And so they cascaded down the walls, and here we can see from rim to river the remnants of these lava flows. And they dammed some of the side canyons. That's down at Whitmore Wash. It dammed the whole side canyon, but they were rapidly eroded away. Well, finally, how old are some of these Grand Canyon rocks? And we touched on this on Tuesday night. But I want to add something else to the story here. We're familiar with the Cardenas basalt. I mentioned it on Tuesday night, deep in the eastern Grand Canyon. They're remnants of these pre-flood lava flows that are now tilted because of the upheavals at the onset of the flood. And we can see them here, a stack of about 7 or 8 large, very thick lava flows stacked on top of one another. And we can reach them. We reach them in the side canyons by hiking in. Of course, we collected samples to date them with the conventional dating methods. And you'll remember the results we got. The potassium-argon method, 516 million years. Using these 3 methods on the same samples, we got 516 million years for potassium-argon, 1,111 million years for rubidium-strontium, and 1,588 million years for samarium-neodymium. The last one is 3 times the first one. So none of these methods agree with one another, so it raises questions as to really how old these rocks are. After all, we know the first one is incorrect because the Tapete sandstone is sitting on top of the Cardenas basalt, so it must be younger, but it has a conventional age of 540 million years. So it can't be 516 million years old. So which age is correct? Probably none of them. Well, here's another interesting bit of the story. We know that the rubidium-strontium age of these Cardenas basalts is 1,111 million years, and even the conventional literature agrees with us that that's approximately the rubidium-strontium age, quote unquote, of these rocks. What about the age of these lava flows in the Western Grand Canyon? 1,143 million years by the rubidium-strontium method. What do you mean? These are so recent, they flowed down the walls of the Grand Canyon after the canyon formed. How can they have the same rubidium-strontium age as the oldest rock, one of the oldest rocks in the Grand Canyon? I mean, for starters, it means that none of these rocks can't be very old. Why? Because if the youngest rock in the Grand Canyon gives you the same quote-unquote age as the oldest rock in the Grand Canyon, we know the recent one isn't very old, then how can we believe either of those ages? Why would they be the same? Well, the answer is because they both come from the same area down inside, deep inside the earth. So what's happened is the rubidium-strontium is not the age, it's the chemistry of the source of the lavas. And it begs the question, if we know that the recent lavas are young and yet they give an old age, how do we know that the old lavas are really old? So none of these methods work. So in conclusion, we've seen tonight that the Grand Canyon is testimony to the truth of God's Word. You know, when we explore the Grand Canyon as we've just done, using our biblical glasses, with our biblical framework, for understanding the evidence, we see that it all confirms what we read in God's Word. And based on the authority of God's Word, rather than human reasoning alone, notice I said alone, God requires us to use human reasoning, but it has to be sanctified human reasoning in the light of the Scriptures. He doesn't expect us to throw our brains away. He expects us to use our brains to His glory. And when we do that, we conclude that all the evidence we see in the Grand Canyon, all the different rock layers and everything about them is testimony to the accuracy of the biblical account of Earth history that we find in the Scriptures.